Okay, so real quick, our warm-up says, which of the following is possible? Answer for the missing side length of A. So we know we've got what kind of triangle here? We've got a 45, 45, 90 triangle, so we pretty much could deduce that A is 4 root 2 from the beginning because they literally gave us the other leg. So we know this is one of the possible choices, and we actually know that that's the most simplified choice. Like that's the one we would write on a test. But this problem was different. It said answer all the possible side lengths of A. So let's pretend they hadn't given us this. If we didn't have this, how would we find A from this number right here? What would we do? Like a step 1, how would you solve? You're just given this problem. You know the hypotenuse is 8, and that's all you know. How would you get from the hypotenuse to the leg?
Divide by square root.
There you go. When you're going forward to the hypotenuse, you multiply. When you're going backwards to a leg, sorry, that's ugly, you divide. And then you rationalize the denominator, and then you get 4 root 2. But 8 divided by root 2 is the exact same number as 4 root 2. It's just not simplified. Okay, let's pretend that we had that back. We've got that 4 root 2 back. And now we didn't notice it was a 45, 45, 90 triangle. And we're just going to use 2 sides of a right triangle. How can you find a missing side if all you have is 2 sides of a right triangle? Pythagorean theorem. So we do 8 squared minus 4 root 2 squared, and we would square root it. 8 squared minus 4 root 2 squared, and we would square root it. So this could be a test problem where we ask you not only what is the most obvious simplified answer, but what other numbers also represent that side length. Okay? First question, what should you do? Okay, so the problem just said, what should you do? First, you analyze what kind of triangle is this. Oh, it's right, and it's isosceles. So 45, 45, 90. So 6, 6, 6 root 2. When you say 6 root 2, you're multiplying 6 by root 2. So the answer was triangle. How could you solve for x? Probably didn't give you enough time on this one. That's okay. So what kind of triangle is this? 30, 60, 90, obviously. The 6 is across from the 90-degree angle, from the right angle. So across from 30 would be 3, because that's half of 6. And then x would be 3 root 3. So how do we get x? First, we had to divide by 2. That got us our shorter side. Then we had to multiply by root 3. So it was a 2-step problem. Divide by 2 and multiply by root 3. What does x equal? So this one is a 45, 45, 90 triangle, right? How do you get from the hypotenuse to a leg? What do you do? Good. You divide by the square root of 2. Now, you can do it the long way. You can divide by root 2. You can rationalize the denominator. Dun, da, 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 and you get 6 root 2 over 2. These cancel out, and you get 3 root 2. But Ms. Tanton told you sometimes in math, things are a coincidence. And sometimes they're a rule, as in it happens every time. And I am telling you, the fact that this is 3 root 2 and 3 is half of 6, that's not a coincidence. That's a rule. That's going to happen every time. So if the hypotenuse was 20, what are the legs? 10 root 2. If the hypotenuse is 40, what are the legs? 20 root 2. If the hypotenuse is 200, what are the legs? Okay, it happens every time Because of this right here, that's why it happens. It's always a 2 in the denominator. So you're welcome to take that shortcut and not show the rationalization every time. You have permission to do that. Okay. What shortcuts would you use to solve? Read all the answers and choose the wisest one. This one was just a teaching moment for me because I wanted you to understand something. You got a list of your Pythagorean triples from the calendar. There was a list of perfect squares and there was a list of Pythagorean triples. So here's the deal. Does Miss Tanton ever want you to factor tree that radical? Not only do I not want you to factor tree it, I don't budget enough time in a quiz. When I put problems on there and I determine how long a quiz should be, I don't give you time to factor tree 81 because I assume you've memorized that that's a perfect square and you're just going to write 9 right away. Likewise, when I put problems on a quiz that are a Pythagorean triple, I don't give you necessarily time to do Pythagorean theorem here. I hope that you've memorized 6, 8, 10. That's a Pythagorean triple. Just like it's 3, 4, 5, you can get new triples from that. Just memorize 3, 4, 5, and then double it. 6, 8, 10. You can triple it. What? 9, 12, 15. Anyways, so if you can memorize some of those Pythagorean triples from that sheet on the calendar, they'll speed up your quizzes, they'll help you not run out of time, and they'll make you a more efficient mathematician. So memorize your triples. That was the moral of that story. Sorry to make it a teaching moment inside the Kahoot. Okay. The length of the hypotenuse as a decimal. I don't really need to go over this one. You did great. 12, 12, 12 root 2. Then you just plug it into your calculator. Every now and then, we don't want the exact answer. We want an approximate answer. It won't be on a problem like this, but it'll be on a real world problem where you have like a word problem and it wants to know the distance, and the distance being 12 root 2 doesn't give you really an understanding of how long it is. So you just plug it into your calculator and get 16 point whatever. Okay, good job. What shortcut should you use to find the length of the dotted line? Oh, that one hurts, guys. I know. You're all going to say the time. I know. But guys, what are the angles of an equilateral triangle? Okay. Immediately, 60, 60, 60. Oh, altitude, bisector. So you should use 30, 60, 90. So when you draw the altitude of an equilateral triangle, you get two 30, 60, 90 triangles. So you didn't need to go this far. You just had to say 30, 60, 90, but this would be 5. It's really ugly. 5 root 3 and 10. X root 3, 2x. And that equilateral triangle will keep coming up a lot in our future units. So make sure you understand equilateral triangle with a altitude draw. Solve for x. Huge hint. This picture was not drawn to scale. The side lengths are not the right length. That's my fault. Not drawn to scale. So what you can always fall back on is Pythagorean theorem. 14 squared minus 7 squared, and then you'd have to factor tree the radicand. What I wanted you to notice here was, how is 7 related to 14? How are those numbers related? What's their relationship? Are you too scared to say? Like if this is x, what's this? 2x. So even though I was given 0 of the angles, if I know two sides of a triangle and they're following one of the rules of my shortcuts, then the third side has no choice but to follow the other part of the rule. Which rule does this go with? 45, 45, 90 or 30, 60, 90? X root 3, 2x. So if your hypotenuse is double one of the sides of your triangle, it's already a 30, 60, 90 triangle. I told you it wasn't to scale because I put the 7 in the wrong spot. But Well, because our answers, that's a good lesson. Our answers always have to be simplified. If you type square root of 147 on a quiz, you don't get credit for it. So I didn't want you to choose that one. You're confusing it with the warm-up where it said choose all possible answers. But normally when it says find the missing side of a triangle, it's understood that you're always given the simplest answer. Always. You never have to ask, do I simplify my answer? Because the answer is always simplify your answer. Yep. Which shortcut should you use? Read all your choices. Nice. It is so tempting to say 3 root 2. It is a right triangle. It is. But what are the angles of this right triangle? We don't know. Unfortunately, there are no tick marks on the side. It doesn't give you one of the angles. So for all we know, this could be 27 and this could be 63. This being 3 root 2 does not make it a 45, 45, 90 triangle. You needed at least one more piece of information. This triangle could have been drawn like this. For all we know, it could have been that, and that could have been the 3 root 2. So be really careful. The answer was you can't solve this triangle. This is an impossible triangle to solve. I don't even know the missing sides because we do not have enough information. Solve for x. Do you know your triples? Because if you know your triples, you'll be faster. If you don't know your triple, then just be a few seconds behind. It's kind of obvious, right? 9, 12, 15. Out of all the choices, that's the only one it really could have been. But that's your 3, 4, 5 triple, and then it's times 3. So, all right, first question. Is the triangle acute, obtuse, or right? If you're watching the recorded lesson, pause it until you're done solving. Okay, step 1, you have to decide which side C is. Less than sign, making it acute. So 120 is greater. C squared is less than A squared plus B squared, making it acute. Very good. So we've got 11 as our C squared. Okay, be ready this time. What is 5 root 2 squared? All right, thank you. All right, so C squared wins this time, making it obtuse. Solve for x. Pause it if you're watching the video and work it out. Amazing job, guys. I'll go over it just to make sure. What'd y'all do first? Well, what'd you do first? Very good. 21 minus 11 gives us 10. And we get to spread it out between these two segments. This is one of your Pythagorean triples I gave you to memorize. 5, 12, 13. 5, 12, 13. It's one of the triples. I use it a lot in our problems. So answer was find x. We got it. It is 12. Awesome job. Ooh, next one. Solve for x. Doesn't really mean find x. We all know where x is. Find the value of x. Okay, this is a good problem. You're going to see this on some homeworks and on the test. Okay, so what? Can you all agree that this is a 90-degree angle, first of all? Because 360 minus 90 leaves us with 90. We've got 3 right triangles that we're dealing with. 2 of them, I made them triples. So this one, there we go. That's prettier. 8, 15, 17, and then 6, 8, 10. Yeah, I always do them from small to large. But yeah, so 8, 15, 17, 6, 8, 10. So those are Pythagorean triples. Even if you didn't know your triples, you should, time me. How long does this take? Ready? 17 squared minus 15 squared. Enter. Square root of 64. Enter. like what? It took me 6 seconds or something. Even if you didn't know the triple, you should be able to put Pythagorean theorem into your calculator very quickly if the answer is a whole number. Yeah.
Isn't it impossible to have 3 right triangles connecting at the right angles to form another triangle?
It's 3D.
What?
It's 3D.
Okay.
Kind of like a pyramid. Okay, so now we've got this going on, and now we've got this going on. Now, for the sake of it being a Kahoot, since it was multiple choice, if you look at that radicand and you couldn't quickly factor tree it, you could have looked at your choices and only one of the choices was a simplified radical. So you easily could have typed square root of 261 in your calculator, and then you could have looked at your choices and you could type 3 root 29 in your calculator and you would have gotten the same thing. So sometimes you use those answer choices to your advantage. The answer was 3 root 29. It was not an easy one to factor tree. Ooh, this is a good one. Solve for x. Right triangle. Yeah, I know. Okay, so we draw that altitude. Good. Thanks for drawing that. You must create a right triangle. If one isn't there, you have to create one. Now, when we draw that altitude, I'm using the word altitude because it hits the opposite side at 90 degrees, we create a 45, 45, 90 triangle. You need to do 22 minus 12 because that 12 segment is congruent to this segment, and we're left with 10. Thank you. So it's 10, 10, 10 root 2, except we didn't need the hypotenuse. It was just asking for x. Okay, clear your annotations, please. Oh, at your school. I was like, my Kahoot music really isn't that loud. Let's make sure we understand how to do this one. So first we can start with our, let's see, there we go. 3 root 2, 3 root 2, 3 root 2, root 2. Which gives us 6. Are we okay with that? Square root of 2 times square root of 2 is 2. So 3 times 2 is 6. You'll discover that, okay, this is 90, this is 45, making this 45 because 90 minus 45 is 45. Oh my goodness, so even though it wasn't drawn to scale, this triangle was congruent to the other triangle. So now we figure out the perimeter. You can only add like terms. So I can add the 6 and the 6, and I can get 12. And then I can add the 3 root 2 and the 3 root 2, getting me 6 root 2. What we cannot do, don't do this. 18 root 2 is not the answer. Never do it. Never combine an integer with an irrational number. They are not like terms. You cannot write them together. You can write them with a plus sign in between. That makes them happy. So 12 plus 6 root 2 was the final answer.